Falsifiability is a philosophical concept most closely associated with the work of Karl Popper, who argued that a key criterion for distinguishing scientific theories from non-scientific ones lies in their falsifiability. According to Popper, a theory is considered scientific if it can be empirically tested and potentially refuted by observations or experiments. This notion challenges the traditional view of verificationism, which posits that a theory is scientific if it can be confirmed or verified by evidence. Falsifiability, therefore, serves as a cornerstone in the philosophy of science, influencing how we evaluate scientific claims and the demarcation between science and pseudoscience. The essence of falsifiability lies in the idea that scientific theories must make predictions that can be tested against empirical observations. For instance, a theory asserting that all swans are white can be falsified by the observation of a single black swan. This potential for refutation is what distinguishes scientific claims from those that are merely tautological or metaphysical. A theory that cannot be tested or potentially disproven is not genuinely scientific, according to Popper. For example, claims about the existence of supernatural entities or phenomena that are inherently unobservable fall outside the realm of scientific inquiry since they cannot be subjected to empirical scrutiny. Popper's emphasis on falsifiability arose as a response to the limitations of verificationism, which was prominent among logical positivists in the early 20th century. Verificationism asserts that a statement is meaningful only if it can be verified through direct observation or logical proof. However, Popper argued that this view fails to account for the nature of scientific progress. He recognized that no amount of empirical observations could definitively verify a universal statement. Instead, he proposed that scientific knowledge advances through a process of conjecture and refutation, where theories are proposed and rigorously tested, with failed predictions leading to their revision or abandonment. This emphasis on falsifiability has profound implications for the scientific method. In practice, scientists develop hypotheses based on existing theories and then design experiments to test these hypotheses. If the experimental results contradict the predictions made by the theory must be reassessed or discarded. This iterative process of proposing, testing, and refining theories is central to scientific advancement. The focus on falsifiability encourages a critical approach to scientific inquiry, prompting researchers to seek evidence that could potentially disprove their hypotheses rather than merely seeking confirmation. The practical application of falsifiability has been illustrated through various scientific revolutions. Consider the transition from Newtonian mechanics to Einstein's theory of relativity. Despite its strengths, the concept of falsifiability has faced criticism and challenges. One major critique is that some scientific theories may be difficult to falsify due to their complexity or the nature of the phenomena they describe. For instance, theories in fields such as psychology or sociology often involve variables that are difficult to control or isolate, making definitive testing challenging. Critics argue that such theories can be valuable despite their lack of straightforward falsifiability. This raises questions about whether falsifiability can serve as an absolute criterion for demarcating scientific from non-scientific theories. Additionally, the phenomenon of ad hoc hypotheses presents a challenge to the strict application of falsifiability. In some cases, when a theory is confronted with evidence that contradicts its predictions, proponents of the theory may introduce new hypotheses or modifications that preserve the original theory. These ad hoc modifications can make a theory less falsifiable, as they can be tailored to accommodate new data rather than subjecting the theory to rigorous testing. This adaptability can blur the lines of what constitutes a genuinely scientific theory, leading to debates within the scientific community about the validity of certain claims. Moreover, some philosophers of science argue for a more nuanced understanding of scientific theories that goes beyond strict falsifiability. Thomas Kuhn, for example, introduced the concept of paradigms in science, suggesting that scientific progress occurs within the context of prevailing frameworks that guide research and interpretation. Kuhn argued that scientists working within a paradigm may resist falsifying their foundational theories until anomalies accumulate to a point that prompts a paradigm shift. This perspective highlights the social and historical dimensions of scientific inquiry, suggesting that the acceptance of theories is influenced not only by empirical evidence but also by community consensus and theoretical frameworks. In addition, the role of confirmation cannot be entirely overlooked. While falsifiability emphasizes the importance of refutation, scientific theories often rely on a balance of both confirmation and disconfirmation. The cumulative nature of scientific knowledge involves gathering supportive evidence over time, which strengthens the credibility of a theory while also remaining open to potential falsification. This interplay between confirmation and falsification is essential in developing a comprehensive understanding of scientific inquiry. Falsifiability remains a vital concept in the philosophy of science, offering a framework for evaluating scientific theories and distinguishing them from non-scientific claims. Karl Popper's emphasis on the potential for empirical refutation has shaped our understanding of the scientific method and the iterative nature of scientific progress. The concept of falsifiability has had a profound impact not only on the philosophy of science but also on the practice of scientific research across various disciplines. As scientists continue to develop and test theories, the principle of falsifiability serves as a touchstone for evaluating the robustness of scientific claims. The application of this principle encourages a critical and rigorous approach to inquiry, fostering an environment where theories are subjected to systematic testing and potential refutation. One prominent example of the application of falsifiability can be found in the field of medicine, particularly in the development and testing of new treatments and interventions. Clinical trials are designed to evaluate the efficacy of new drugs or therapies against specific hypotheses. For instance, a hypothesis might assert that a new medication reduces symptoms of a disease more effectively than a placebo. The trial's design includes a control group receiving the placebo, allowing researchers to test the hypothesis rigorously. If the results show no significant difference between the treatment and the placebo, the hypothesis is falsified, prompting a re-evaluation of the drug's efficacy. This reliance on falsifiability ensures that medical research is grounded in evidence, ultimately leading to more effective treatments and therapies. In psychology, the challenges of falsifiability are particularly pronounced due to the complexity of human behavior and the multitude of variables involved. However, many psychological theories strive to incorporate falsifiable elements. For example, theories of cognitive behavior may propose that specific interventions can lead to measurable changes in behavior. Researchers can design experiments to test these predictions, allowing for the potential falsification of the theory if the expected changes do not occur. Despite the inherent difficulties, the commitment to falsifiability in psychological research encourages the development of testable hypotheses, ensuring that theories are subject to empirical scrutiny. The application of falsifiability extends to social sciences, where researchers often grapple with the challenges of measuring complex social phenomena. While some theories in sociology may seem resistant to empirical testing, scholars often seek to operationalize their hypotheses in ways that allow for potential refutation. For instance, a theory positing that socioeconomic status influences educational attainment can be tested using statistical methods to analyze large data sets. If the data do not support the theory's predictions, it can be revised or abandoned. This practice underscores the importance of falsifiability in the social sciences, promoting a more rigorous approach to understanding societal dynamics. Despite its strengths, the principle of falsifiability is not without limitations. Critics argue that the strict application of falsifiability. This concern is echoed in the work of philosophers like Imre Lakatos, who proposed a more nuanced understanding of scientific research programs. Lakatos argued that scientific theories should be evaluated not in isolation but as part of a larger research program that includes a series of interconnected hypotheses. Within this framework, a theory may survive falsification if it can be modified or adjusted in response to new evidence while maintaining its core principles. This perspective allows for the evolution of scientific theories over time, accommodating the dynamic nature of scientific inquiry and the interplay between confirmation and falsification. In addition, the rise of computational methods and data-driven approaches in science has prompted further reflection on the role of falsifiability. The advent of machine learning and artificial intelligence has transformed how researchers analyze data and generate hypotheses. While these technologies can yield valuable insights and predictive models, they also raise questions about the transparency and interpretability of the underlying algorithms. In this context, the concept of falsifiability must be adapted to address the challenges posed by complex computational models, ensuring that they remain subject to empirical validation and critical scrutiny. Furthermore, the principle of falsifiability has implications for the public understanding of science. As scientific knowledge becomes increasingly complex and nuanced, the concept of falsifiability can serve as a valuable tool for promoting scientific literacy. By emphasizing the importance of empirical testing and the potential for theories to be disproven, educators can foster a critical mindset among students and the public. This understanding encourages individuals to engage with scientific claims thoughtfully and to recognize the provisional nature of scientific knowledge. Falsifiability remains a central tenet of the philosophy of science, influencing how we evaluate scientific theories and claims. Karl Popper's emphasis on the potential for empirical refutation has shaped the scientific method and encouraged a rigorous approach to inquiry across various disciplines. While challenges to the strict application of falsifiability exist, particularly in fields such as psychology, sociology, and advanced theoretical sciences, the principle continues to serve as a guiding framework for scientific research. As we navigate the complexities of modern scientific inquiry, the commitment to falsifiability encourages critical evaluation, empirical testing, and a recognition of the evolving nature of scientific understanding. By fostering an appreciation for the provisional character of scientific knowledge, we can cultivate a more informed and engaged society, equipped to address the pressing challenges of our time. The discussions surrounding falsifiability also extend into the realm of ethics in scientific research. As scientists navigate the complexities of hypothesis testing and theory validation, ethical considerations play a crucial role in how research is conducted and reported. The principle of falsifiability can inform ethical practices by emphasizing the importance of transparency and integrity in the scientific process. When researchers acknowledge the potential for their hypotheses to be falsified, it encourages a culture of honesty about the limitations and uncertainties inherent in scientific inquiry. One ethical concern related to falsifiability is the pressure on researchers to produce positive results. In many fields, there is a tendency to publish findings that confirm existing theories or demonstrate significant effects, often referred to as the publication bias. This bias can lead to a distorted view of scientific progress, where failed experiments or inconclusive results are underreported. By fostering a culture that values falsifiability, the scientific community can encourage researchers to share negative findings or instances where hypotheses are not supported by evidence. This transparency is essential for a complete understanding of scientific phenomena and promotes a more accurate representation of the state of knowledge. Moreover, the interplay between falsifiability and replicability is a critical aspect of scientific integrity. Replicability refers to the ability of independent researchers to reproduce the results of a study using the same methods and conditions. A theory that is falsifiable should ideally yield consistent results across different studies. However, the replicability crisis, particularly in psychology and social sciences, has raised concerns about the robustness of many published findings. By emphasizing the importance of rigorous testing and the potential for theories to be challenged or refuted, the principle of falsifiability encourages a commitment to replicable research practices. This commitment not only strengthens scientific knowledge but also enhances public trust in scientific findings. In addition, the implications of falsifiability extend to interdisciplinary research. As scientific fields increasingly overlap, the need for a common framework for evaluating theories becomes paramount. Falsifiability provides a versatile criterion that can bridge disciplines, facilitating communication and collaboration among researchers from diverse backgrounds. For instance, in addressing complex global challenges such as climate change or public health crises, interdisciplinary teams often draw on theories from environmental science, economics, sociology, and health sciences. Falsifiability serves as a shared principle that encourages these teams to rigorously test their hypotheses and integrate findings across disciplines, ultimately leading to more effective solutions. The concept of falsifiability also plays a role in public discourse about science. As scientific claims gain prominence in societal debates, ranging from climate change to vaccine safety, the ability to critically evaluate these claims becomes essential. Falsifiability serves as a tool for the public to assess the validity of scientific assertions, fostering a more informed citizenry capable of engaging with scientific issues. By understanding that scientific theories are inherently provisional and subject to change based on new evidence, individuals can approach scientific claims with a critical mindset, recognizing the importance of empirical testing in validating knowledge. Falsifiability remains a fundamental principle in the philosophy of science, shaping how we evaluate theories and claims across various disciplines. Karl Popper's emphasis on the potential for empirical refutation has not only influenced scientific methodology but has also informed ethical practices, interdisciplinary collaboration, and public understanding of science. While challenges to the strict application of falsifiability persist, particularly in the context of complex and advanced scientific inquiry, the principle continues to serve as a guiding framework for scientific research. As we face pressing global challenges and navigate the intricacies of modern science, the commitment to falsifiability fosters critical evaluation, transparency, and integrity in the pursuit of knowledge. Ultimately, embracing the provisional nature of scientific understanding enables us to engage thoughtfully with the public complexities of the world, ensuring that science remains a dynamic and responsive endeavor. As we delve deeper into the implications of falsifiability, it becomes evident that this principle is not merely a philosophical abstraction but a practical necessity for the advancement of scientific knowledge. the commitment to falsifiability encourages a culture of skepticism and inquiry, prompting scientists to question existing theories and seek out new evidence. This spirit of inquiry is essential for scientific progress, allowing for the refinement of theories and the development of more comprehensive explanations of natural phenomena. One area where the influence of falsifiability is particularly noteworthy is in the realm of scientific paradigms. According to Thomas Kuhn, scientific progress occurs within paradigms, frameworks that guide research and shape the questions scientists ask. While Kuhn acknowledged the importance of established paradigms, he emphasized that anomalies or contradictions can arise, leading to a crisis that may prompt a paradigm shift. Falsifiability plays a crucial role in this process, as it allows scientists to critically assess the limitations of existing paradigms and explore alternative theories. When experimental results fail to align with the predictions of a prevailing theory, the potential for falsification can catalyze the exploration of new paradigms, ultimately leading to scientific revolutions. Moreover, the role of falsifiability in technological advancements cannot be overlooked. As scientists develop new technologies and methodologies, the principles of empirical testing and potential refutation become critical. For instance, in fields such as genetic engineering and artificial intelligence, researchers must rigorously test their hypotheses and the implications of their innovations. By applying the principle of falsifiability, scientists can ensure that their technological developments are grounded in robust evidence, minimizing the risks associated with untested theories. This iterative process of testing and refining technologies not only enhances their effectiveness but also ensures that ethical considerations are addressed, particularly in applications that may have significant societal impacts. In addition, the concept of falsifiability intersects with science communication and public engagement. As scientific discoveries increasingly shape societal issues, effective communication becomes essential. By highlighting the importance of falsifiability, scientists can help the public understand that scientific knowledge is not static but rather a dynamic process subject to revision based on new evidence. This understanding can foster public trust in science, as individuals recognize that scientific claims are grounded in rigorous testing and that scientists are committed to updating their beliefs in light of new findings. Effective science communication that emphasizes falsifiability can empower individuals to critically evaluate scientific claims. Furthermore, the principle of falsifiability can inform the development of science education curricula. By integrating the concept into educational frameworks, educators can cultivate a critical mindset among students, encouraging them to question assumptions and engage in empirical inquiry. Teaching students about the iterative nature of scientific research, where hypotheses are tested and potentially falsified, can instill an appreciation for the scientific method and its role in advancing knowledge. This educational approach not only prepares future scientists but also equips students with the skills to navigate an increasingly complex world where scientific literacy is paramount. The challenges posed by pseudoscience also highlight the importance of falsifiability. Pseudoscientific claims often lack the rigor of empirical testing and are not subject to potential refutation. This can lead to the acceptance of theories that may appear plausible but are not supported by scientific evidence. By promoting a clear understanding of falsifiability, scientists and educators can help the public distinguish between legitimate scientific claims and pseudoscientific assertions. This distinction is crucial in an era characterized by misinformation and the rapid spread of unverified claims, as it empowers individuals to critically assess the validity of various assertions. Falsifiability is a foundational principle that shapes the philosophy of science and informs the practice of scientific inquiry across multiple disciplines. Its emphasis on empirical testing and the potential for refutation fosters a culture of skepticism, inquiry, and integrity within the scientific community. As we navigate the complexities of modern science, the commitment to falsifiability serves as a guiding framework for ethical research practices, interdisciplinary collaboration, and effective science communication. By embracing the provisional nature of scientific knowledge, we can cultivate a more informed society capable of engaging with the challenges of our time. Ultimately, the principle of falsifiability not only enhances our understanding of the natural world but also empowers us to approach scientific inquiry with curiosity, critical thinking, and a willingness to adapt in the face of new evidence. Falsifiability, a cornerstone concept in the philosophy of science introduced by Karl Popper, offers a profound lens through which we can scrutinize and assess the validity of scientific theories. At its core, falsifiability posits that for a hypothesis or theory to be considered scientific, it must be potentially disprovable through empirical evidence or observation. This criterion sets a pivotal standard for distinguishing between scientific theories, those that can be tested and potentially refuted, and non-scientific claims that evade empirical scrutiny. By emphasizing the significance of falsifiability, Popper aimed to delineate the demarcation between scientific endeavors and pseudoscience, superstition, or unfalsifiable claims. In the realm of scientific inquiry, the principle of falsifiability serves as a robust criterion for evaluating the empirical adequacy and testability of hypotheses, theories, and models. It invites scientists to formulate hypotheses that are specific, precise, and open to potential falsification through empirical testing, experimentation, or observation. The concept of falsifiability challenges us to embrace intellectual honesty, empirical rigor, and critical scrutiny in our scientific pursuits. It underscores the provisional nature of scientific knowledge, the fallibility of theories, and the necessity of subjecting hypotheses to empirical testing and potential refutation. By acknowledging the principle of falsifiability, scientists engage in a continuous process of hypothesis testing, data analysis, and theory revision that enriches the fabric of scientific knowledge and propels the advancement of empirical inquiry. Moreover, falsifiability fosters a culture of intellectual openness, curiosity, and skepticism within the scientific community. It encourages scientists to subject their theories to rigorous scrutiny, challenge prevailing assumptions, and remain vigilant against confirmation bias, dogmatism, or unwarranted certainty. By embracing the principle of falsifiability, scientists uphold the virtues of intellectual humility, epistemic integrity, and empirical accountability, fostering a scientific ethos grounded in critical thinking, evidence-based reasoning, and openness to revision in light of empirical findings. In the realm of scientific discovery, falsifiability serves as a guiding beacon that illuminates the pathways to empirical truth, theoretical progress, and intellectual growth. By adhering to the principle of falsifiability, scientists navigate the complexities of hypothesis testing, theory evaluation, and empirical validation with a spirit of curiosity, rigor, and intellectual honesty. Through the lens of falsifiability, we embark on a journey of scientific exploration that celebrates the pursuit of truth, the spirit of inquiry, and the quest for knowledge that transcends the boundaries of our current understanding. In the realm of scientific inquiry, the principle of falsifiability not only serves as a criterion for demarcating scientific theories from non-scientific claims but also as a catalyst for intellectual progress, theoretical refinement, and empirical discovery. By subjecting hypotheses to the crucible of empirical testing and potential falsification, scientists engage in a dynamic process of hypothesis refinement, theory revision, and knowledge expansion that propels the frontiers of scientific understanding. The practice of falsifiability invites scientists to embrace the virtues of intellectual humility, curiosity, and skepticism as they navigate the intricate landscape of empirical inquiry. It encourages a culture of critical thinking, evidence-based reasoning, and openness to revision in the face of empirical evidence that challenges prevailing theories or hypotheses. Through the lens of falsifiability, scientists cultivate a mindset of epistemic resilience, scientific integrity, and intellectual rigor that underpins the quest for empirical truth and theoretical coherence. Moreover, the principle of falsifiability underscores the provisional nature of scientific knowledge and the fallibility of human understanding. It reminds us that scientific theories are subject to revision, refinement, and potential falsification as new evidence emerges, experimental techniques evolve, and theoretical frameworks undergo scrutiny. By acknowledging the principle of falsifiability, scientists embrace a spirit of intellectual openness, methodological rigor, and theoretical flexibility that enriches the scientific enterprise and fosters a culture of scientific progress and innovation. In the grand tapestry of scientific discovery, falsifiability stands as a beacon of intellectual integrity, empirical accountability, and theoretical robustness. By upholding the principle of falsifiability, scientists uphold the ideals of empirical scrutiny, theoretical coherence, and intellectual honesty that lie at the heart of the scientific method. Through the practice of falsifiability, we embark on a collective journey of exploration, discovery, and knowledge acquisition that illuminates the pathways to scientific truth, theoretical advancement, and intellectual enlightenment.